Indoor positioning systems play a very critical role in our lives recently. They are used for navigation in indoor environments where GPS signal is unreachable due to signal attenuation. Ranging forms a very basic principle for indoor-based positioning. The time-of-flight-based ranging approach is widely used in literature due to its accuracy in line-of-sight conditions. However, its accuracy begins to dwindle or surface in non-line-of-sight conditions.
Regarding our experiment, two different environments are considered. In the first environment, we set up 5 ultra-wideband anchors, and then we use 1 ultra-wideband tag. So objects of different permittivity affect the ranging results differently. So in our environment that we consider, we have different objects of different relative permittivity. We have a plasterboard wall where the signal is going to traverse through, and then we have an object of a higher permittivity, which is a concrete wall. So in one of the environment, we set up all the anchors in line of sight. We have the first anchor, we have the second anchor, and then we have the third anchor. So after we set up these 3 anchors in line of sight, we have a very busy corridor with people also moving on the corridor, which also is going to affect the ranging results. And then we have set up 1 non-line of sight. With 3 anchors set up in line of sight in this room, and then 1 placed in non-line of sight in the other room, we set up another extra anchor, which is the 5th one, in non-line of sight conditions where we place it on the corridor. For localization, the tag tries to range all the surrounding anchors, and we try to log the channel impulse response and the time of flight of the ranging. So after logging 100 time of flight ranging at this position, we move the tag to another distance, which is 2 meters from the original position. We do this in a square grid pattern to cover the whole environment.
During ranging, we observed that the line of sight measurements were stable compared to the non-line of sight measurements. So based on this insight, we decided to observe the ranging variance or stability to decide whether a ranging result was received in line of sight or in non-line of sight. A higher weight is then assigned to the line of sight measurement, and a lesser weight is assigned to the non-line of sight measurement to improve localization results. So we compare the performance of our approach in the 2 considered environments. Thank you very much for watching this video.